This is a fire that many of you will be familiar with and is another example of external fire spread. And we've captured a few stills from another number of videos that were taken during the fire. That's the property in its heyday. And this is a photograph of the fire developing on the 11th floor, it having already become fully developed in the flat 2 levels below. Once the fire had begun to develop there, we noticed below that there are a number of windows that are open at lower levels, and behind those windows there are net curtains. And during the course of the fire developing on the 11th floor, fragments of burning material were dropping. We think that there's a potential here for drafts, as the wind was blowing for a while on this face of the building, to cause these burning fragments to get drawn into windows that were at lower levels. Some of these windows were of both the tilt and vertical hinge variety, but most of them were actually hinged, vertically hinged in the open position. And so now you can see a fire developing at lower level, I think on the 5th floor, and subsequently the fully developed fire on the 11th, and now a developing fire on the 7th. So quite alarming mechanisms by which the fire is communicating from one floor to the next. The next case study is one involving a high-rise flat in Glasgow, which originated in one of the upper floor flats, the one that's arrowed, but didn't develop to any significant proportions. Unfortunately, it claimed the life of the occupant, and the fire seems to have started amongst the electrical equipment close to a cupboard and near to the bed where the occupant was sleeping. Within that cupboard there was galvanised steel ducting that at the bottom of the cupboard communicated via the drop there to the flat below, and a similar duct at the top that communicated with the flat above. And it is by this means, because there was no proper stopping around the duct, that the fire communicated to the cupboard at the next flat up, and where it became fully developed. Service risers are, of course, a well-known problem area, and we've encountered many examples of inadequate fire stopping of fire risers which have facilitated fire spread, unfortunately, into common areas which, of course, will be used as means of escape. And because the vertical risers are invariably completely open from top to bottom, apart from within the cupboard where the fire stopping should take place, the fires can spread very rapidly. First of all, here we see, I'm sure many of you are familiar with this, the cupboard where the service equipment is located on a common passageway, where there is an adequate installation of fire stopping at the horizontal division, and where pipes pass through into the ceiling void, the suspended ceiling void, over the corridor, with both the board and the intumescent stopping formed in around the cables. Unfortunately, where such precautions are not put in place, fires can spread very rapidly on large bunches of PVC insulated cables, and spread quickly up the riser, as I've indicated, and then into the void space above the common passageway, which, because of the enormous quantities of smoke that are produced, can impede means of escape. And here we see cables emerging from the top of the cupboard straight into the ceiling void. And they're an example of the gas pipe in similar vein. Concealed voids, of course, are also a problem, and in modern buildings where one has metal-framed suspended ceilings with incombustible ceiling panels, that is less of a problem, apart from the fuel loading that is provided by any services that pass through the void. But in the Decent Homes initiatives, one has to be very careful that if new suspended ceilings are being installed, these do comply in every respect with the building regulations and appropriate guidance. Here's an example of a suspended ceiling that had been fitted to timber stud work as a retrofit, through which a lot of services passed. And although the underside of the ceiling structure was class 0 in terms of fire spread, as were the walls, once the fire got into the void, it had not been stopped, and there was an opportunity for the fire to spread from one end to the next. And that the arrow points to an area where there was once a window that's now been boarded over. Fortunately, in that particular instance, the boarding had been fitted well, and the structural fire precautions in terms of compartmentation were maintained, both in respect of the fire not spreading into the flat, or in other cases the fire spreading from the flats into the void. Wood frame buildings. We've had a number of spectacular fires recently in the last 5–10 years with such buildings under construction. The fire brigades and the local authorities have become very concerned about these. The problem is, of course, that when they're partially constructed, they're tinder boxes. They're the absolutely perfect crib, wooden crib, for a fire spread from top to bottom, with enormous radiant heat fluxes impinging on pre-existing buildings and causing damage to those in the neighbourhood. But this is a fire that should have been no more than a few £1,000s, that started in a little cupboard where the consumer's installation equipment was located. The route by means of which the cables passed into the cavity of the preformed modular timber construction had not been stopped, and so the fire got into this cavity. And of course, the cavities are bounded on both sides by oriented strand boards, which have a load-bearing requirement, and this is depended upon in these structures. And here we have an example of the way in which the fire, once it's been opened up, has been progressing like a rat in a drain pipe throughout the building. And although the means of escape were not compromised because this was a very slow process, of course the costs are phenomenal, and also the exposure of the fire brigade to the risk of the building structure losing its integrity is also a serious consequence. So we see the fire having progressed within the cavity from the lower level, and in another example, the fire descending from ceiling level to affect the strand boarding at the lower level. This is an example not so much of a high-rise problem, but I suspect there might be examples where combustible moisture thermal barriers are used. It's an interesting case because a brand new building and the occupier was using a blow lamp to extend the external water supply to a tap that he wanted to put at a higher level. And because he hadn't drained the water sufficiently from the copper pipe, he needed to apply the blow lamp for much longer to get it to a temperature at which the solder would flow. And it wasn't long before his wife said, "There's smoke coming into the bathroom, the kitchen on the first floor. What's going on?" And for the next 2 or 3 hours, the fire propagated throughout the cavity because having opened up the cavity from the inside, we found evidence of these moisture barriers, thermal and moisture barriers, which are, as you probably know, a composite of a plastic liner with almost a sort of polyethylene bubble wrap sandwiched between thin metal foil on the outside as a thermal barrier. And the fire communicated throughout the whole of the cavity of the building, extended to the neighbouring building, and also because there was no, this is a test that I did to show how easy it is to ignite and spread flame, and then because there was no cavity closure in the roof, it spread into the roof and just ignited the felt Fortunately, the fire brigade had got to this part of the building in time, but in fact they were chasing this fire, rather like the wood frame building fires, by having to break open the internal wall blocks at various levels to insert water and to make sure that it had been brought under control.